Hello again, welcome to another lesson in geometry. Today we are covering section 8-3 on trigonometry. Okay, so we'll spend 2 days in class working on this, so you might want to come back and watch this video a second time after the first day of class. Just make sure that's starting to make more sense, okay? All right, so the Venn diagram at the right shows a relationship between similar and congruent figures. Write T for true or F for false. So notice similar figures as congruent figures inside of it. So every congruent figure is also a similar figure. So all similar figures are congruent. This is false. The ones that are out here are similar but not congruent. Okay. All congruent figures are similar figures. This is true because every figure in here is also in there. Okay. Some similar figures are congruent figures, and this is also true. The ones that are in here are also congruent, and the ones that are out here are not. Okay. Circle the postulate or theorem you could use to verify that the triangles at the right are similar. So we don't see any sides marked on here that are proportional, but we can see two angles are the same for each. So this would be angle-angle postulate. Okay, so remember for this one we have to have 2 sets of proportional sides, and this one we have to have 3 sets of proportional sides. Neither one of those work for us. All right, vocabulary builder, ratio. A ratio or rate or rational are all some related words. We have definition. A ratio is the comparison of 2 quantities by division. And there are 6 triangles and 5 squares. The ratio of a triangle to square is 6 to 5, or the ratio of squares to triangle is 5 to 6. And you've done this many times, and you've even compared them together to do proportions. Okay, so this is not new. So use the triangle at the right for exercises 5 through 7. Circle the ratio of the length of the longer leg to the length of the shorter leg. Okay, so the longer leg is 12, so it's the long leg. This is the short leg, and this is our hypotenuse. So the ratio of the long leg to the short, so the long to the short would be 12 to 5. That's this one. Circle the ratio of the length of the shorter leg to the length of the hypotenuse. The short leg is 5, the hypotenuse is 13, so that ratio would be 5 to 13. Circle the ratio of the length of the long leg to the length of the hypotenuse. The long leg is 12. And the hypotenuse is 13, so that's going to be 12 to 13. Now remember, we're not going to use 13 to 12 because that's the ratio of the hypotenuse to the long leg. It matters in which way it reads, okay? All right, let's flip it over. Key concept here. Our first key concept is trigonometric ratios. All right, and we have 3 of them, so there's 3 new words here, and they seem all complicated, but they're really not that bad. We have sine, cosine, and tangent. Sine, cosine, and tangent are based upon an angle, and the angle is not going to be our right angle in a right triangle here. So we have angle A, or we could do them based on angle B. And they're just the ratio of the 2 sides that touch or don't touch angle A. Okay, so the sine of angle A is the side that's opposite. Okay, that would be A's little side, over the length of the hypotenuse. So the length of the opposite leg from A over the length of the hypotenuse. Okay, so it's better to memorize it as this, opposite over hypotenuse. So the cosine of angle A is the leg that is adjacent to angle A and the hypotenuse. So the length of the leg adjacent to angle A is B, and the length of the hypotenuse is C. That's why there was a C down here. And then the tangent of angle A is the leg that's opposite. Okay, opposite was angle or length A over the adjacent, and the adjacent was length B. So A over B. All right. Now, there is a nice thing to help you memorize this because it's really important to memorize. So the sine is, of course, the opposite over the hypotenuse, and the cosine is the adjacent over the hypotenuse. And the tangent is the ratio of the opposite over the adjacent. Okay, now if we take all those and put them together, we end up with this. So, let's see, that's supposed to be an H there. So, ka, toa. Okay, So SOHCAHTOA is what you'll see in most math books or most things on the web if you Google like trigonometry ratios, how to memorize it. And that just says the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. Okay? All right, so draw a line from each trigonometric ratio in column A to its corresponding ratio in column B. Now, remember, we can use either angle. So now they're talking about angle B. So angle B, sine. Sine is supposed to be opposite, SOHCAHTOA, so opposite over hypotenuse. So that's going to be B over C. Cosine. So erase again. Cosine is ka in SOHCAHTOA. So cosine is going to be the ratio of the adjacent one, the one that touches it, the leg that touches it, to the hypotenuse. So A over C. And then tangent, TOA, and our little way to help us memorize it. So SOHCAHTOA. So that's tangent is opposite over adjacent. So for B, opposite is B, and adjacent is A. So B over A. Okay? All right. Reasoning. Suppose triangle ABC is a right isosceles triangle. What would the tangent of angle B be? All right, so let's think about this. A right isosceles triangle. So isosceles triangle means two sides are the same. So this side and this side are the same, and then we'd have the hypotenuse. Now we know something about this kind of triangle because this is a 45, 45, 90 triangle. And we know that the legs are equal. So if we asked what is the tangent of angle B, so this would be angle A, angle B, and angle C is always our right angle here. Tangent of angle B is going to be the leg opposite over the leg adjacent. They're going to be the same length though. Okay, so this is going to be the same number divided by the same number is going to be 1. So what would the tangent of angle B equal? It would equal 1 because in a 45, 45, 90 triangle, the adjacent leg and opposite leg are both equal. Okay, so we're using the TOA. So that means that tangent is the opposite over the adjacent. And since they're both equal, that's going to be 1 in our case. Not always, but in our case. All right, so in problem number 1, we have writing trigonometric ratios. So what are the sine, cosine, and tangent ratios for angle G here? So remember, it matters based on the angle we're looking at. So if I'm looking at angle G, of course, its opposite and adjacent are different than if I was looking at angle T. Okay, so circle the measure of the leg that is opposite of G. Opposite of G, its leg is going to be 15. Circle the measure of the hypotenuse. The hypotenuse is always opposite of the right angle, so in this case it's 17. And circle the measure of the leg that is adjacent to G. Adjacent is the one that touches it. Well, it touches the hypotenuse always, but it also touches 8. 8's the leg it touches. Okay. All right, so write each trigonometric ratio. So remember we have SOHCAHTOA to help us out. Okay, so sine's going to go with the opposite over the hypotenuse. So the opposite of G is 15. The hypotenuse of G is 17. So 15 over 17. Okay, cosine's going to go with the adjacent and the hypotenuse. Cosine is ka. So the 8 is the adjacent, 17 is the hypotenuse, so 8 over 17. And then tangent's going to go opposite, that's the TOA, over adjacent. Opposite of G is 15, and adjacent to G is 8, so 15 over 8. Okay? All right, so quick thing here. When I was a kid, we didn't have a calculator. So let's say you wanted to find out, like, what is the sine of 30 degrees? So in other words, what would be the ratio in a 30, 60, 90 triangle of the opposite compared to the hypotenuse? Now remember, it doesn't matter what lengths they are. The 30, 60, 90, it doesn't matter because all 30, 60, 90 triangles are similar. So there's only one answer for this, regardless of how big the triangle is. When I do the ratio of the opposite to the hypotenuse, we're going to get the same number. So I had tables, because our calculators couldn't do this, and I had to look up what is a 30 degrees and then go across and find the value of sine. And that told me the ratio of the opposite to hypotenuse. Okay? So you're going to be doing that, except you can use a calculator to type in the sine of 30 now. All right? So we're going to take a look at problem number 2. Use a trigonometric ratio to find the distance, W, in this triangle here. So find the value of W to the nearest tenth. So we have a 54, 90, and what would be the complement of 54, which is 36 triangle. All right, so we know that our calculator can find out either the sine or the cosine or 54. Okay, you don't even have to look up a table like I used to. Okay, so we could do a problem. Let's take a look at 54 here. That's the angle we know. W, the length we're looking for, is the opposite of that. So I have opposite, and then across from the 90 is 17, and I have hypotenuse. Which of our things go with opposite and hypotenuse? And this is why it's useful to remember this. This is SOHCAHTOA, and that means we're going to be using sine. So we should have sine to make this work. Sine is opposite and hypotenuse. All right. So below is the student solution here. Did they use sine? No, they used cosine. So that's what's wrong with this. So circle the trigonometric ratio that uses sides W and 17. So one more time, I'll erase it up here. W is opposite of 54, so we're going to be using the opposite. And 17 is the hypotenuse of the triangle, so we're using the hypotenuse. And sine goes with opposite and hypotenuse. So what error did the student make? They used the wrong trigonometric function. And I'm going to shorten that to trig function. Okay? Find the value of W correctly. So let's do this correct. Okay? So we know that the sine of the angle, so we know our angle this time is 54, and that should be equal to the ratio of the opposite, which was W, divided by the hypotenuse, which was 17. And then I can just solve for W by timesing both sides by 17. Okay, so 17 times the sine of 54 equals W. And then this is where a calculator comes in handy. Okay, so I'll turn on my calculator and type this in. So 17 times the sine of 54. Okay, and when I type that in, I get 13.8. And this is rounded. Okay, so what is the value of W to the nearest tenth? 13.8. Okay, so next time in class, I will show you how to work our calculators to make this work, because there are two modes your calculator could be in finding trigonometric functions, and we didn't make sure that we are in the correct mode. And if you use your own calculator at home, bring it in and I'll make sure your calculator is in the correct mode also. Okay, because we're going to put it in the degree mode, not radian mode. All right, problem number 3, using inverses. So use the figure below. What is the measure of angle Y to the nearest degree? Okay, so like we said, all triangles of any degree measures, any pairs of them, are the same, always going to have the same trigonometric function because they're all going to be similar. So we're going to use our knowledge to help us figure out an angle by doing the ratio of the sides that we know. Okay, so circle the lengths of the sides that we know here. Well, we don't know the hypotenuse. Okay, that's the one across from 90. We don't have that. But we do have the side adjacent to Y, that's 41. And we have the side opposite of Y, that's 100. Okay? Cross out the ratio that you will not use to find the measure of angle Y. Okay, so let's see. We have SOHCAHTOA again. SOHCAHTOA. And let's see, we don't know the hypotenuse, so sine's out of the question. We don't know the hypotenuse, so cosine's out of the question, but we do know the opposite and adjacent. So we're going to use tangent, and we are not going to use cosine or sine. So underline the correct word to complete the statement. If you know the sine, cosine, or tangent ratio of an angle, you can use the inverse to find the measure of the angle. So if I know them, I can use the inverse to get it, okay? All right, so let's flip it over because I'm pretty sure the rest of our problem's on this side. Follow our steps here. So we knew the tangent of angle Y was equal to 100 over 41. 100 was the opposite and 41 was the adjacent. So if we flip back and look, our opposite and adjacent are 141. Okay. Use our inverse here. So Y is going to equal to the inverse function of tangent, okay, of 100 over 41. And I will show you how to do this on your calculator next time. Okay, but you should have an inverse tangent button if you have a calculator at home. And if you're in the right degree mode and not radian mode, you're going to get this when you type it in. 67.706, bunch of other stuff. And we're asked to round this to the nearest degree measure, so we'll round this to 68 degrees. So given two sides of a triangle, we can find the angles using one of our trigonometric functions, sine, cosine, or tangent. All right, so that leads us to the lesson check. As always, pause the video and then come back and check it over. Okay, so here's our lesson check. So do you understand? And it's an error analysis. So a student states that the sine of angle A, okay, so the ratio of the opposite over the hypotenuse for angle A there, is going to be bigger than the ratio of the opposite to the hypotenuse for angle X in that little triangle. Okay, what is the student's error? Explain. Okay, so let's think about this for a second. Both of these triangles have the same angles, right? So that means they are similar triangles. We're not comparing the size, so changing the size of a triangle is not going to change the ratio of its sides. And that's because all the sides in similar triangles are proportional, okay? So angle AB, or triangle ABC and triangle XYZ are similar triangles. Similar triangles are going to have proportional sides. So their ratios are going to be the same, okay? So angle A and angle X are congruent. So the sine of 35 is equal to the sine of 35. The ratios of the opposite to the hypotenuse will always be similar. So what's the student's error? So this is what I think the student thought. The student thought that the bigger triangle will have bigger values. Sine, cosine, and tangent. Okay? And that's wrong. Okay? Remember, it's the ratio of the sides, and since the sides are all proportional, the ratios stay the same for all triangles that are similar. Okay? So in this case, just because ABC looks bigger than XYZ does not make its sine be bigger. When I divide a bigger one by the other bigger one, I'm going to end up with the same answer in the end. So the sine of 35 is always equal to the sine of 35. The ratios are always going to be the same because all the triangles are similar to each other. Okay? So check off the vocabulary words that you understand. Trigonometric ratios, those are sine, cosine, tangent. You should know what they are. Now, understanding what they are, probably a little bit harder for you guys. So go back and watch the video one more time, most likely, and then come back in. We'll practice it. We'll talk about it some more, and then I really suggest watching the video the second night, even though it's not assigned, okay? And then it'll make more sense to you the longer we work on it. So hopefully you're in the 8 to 10, but I'm kind of guessing that you'll need a little work to get there. That's why we're spending 2 days on this section. All right, see you in class next time.